All right. Well, good evening, everyone. Welcome to the February edition of the Ottawa Centre meeting. Thanks for coming. I know it's not a brutally cold night, but it still is cold, and I guess a bit of snow. We got a couple of announcements and a couple of changes to the meeting tonight. So let's go right to the next slide, please. Okay. On the agenda, what we have tonight, we have Gordon Webster is going to talk about the F.L.O, as I mentioned. He's going to give an update. Recall last time that we talked about a tour of the Fred Lossing Observatory, the Ottawa Centre's observatory for members. We now have 37 people that have signed up for the tour. Gordon is working with Ron St. Martin to organize that, and he'll talk about that as well, and also with the plans for the year ahead, and an area where we could use some help. As well, we have Carmen Finstad. She's our new AstroNotes editor. She's going to talk about AstroNotes, okay, we're looking like it's coming along. Perfect. And follow that, we're going to have Al Scott. He's going to give his usual 10-minute astronomy news segment. No Ottawa skies this month. That'll resume next month. We have one change in the agenda tonight, and that's Ryan Anderson. He's got a bit of an emergency, so we're going to put him to the next month. So we're going to instead, what we're going to do is, instead of having Carmen after the break, we're going to bring you and your fascinating presentation, and you can take as long as you want. So the good thing is that we're not going to be rushed tonight, so we can have lots of interaction with the observer reports after the break. And it'll be a relaxed meeting, that's for sure. No time rush. So next slide, please. Okay, I always like this portion of the meeting. It's a couple of new members. Richard is a member. David Lawson, Graham, Eric, Jane, Brian, and Bruce. So we're off to a good start in January. So thanks for joining. And we have membership cards that are available from Al Fraser. Okay. So thank you for those and welcome. Next slide. So members in the news, a couple of things here which are interesting. By the way, as I said in my email to the members here, you're going to notice tonight that we've been after we've always had a few challenges in this venue here. It's after the last meeting, we Bob, myself, and Chris, we hung around quite late to try and figure out what's going on for a resolution. So we beefed it up quite a bit. We think we've I cross your fingers, and we've figured it out tonight. So I think you're going to see some impressive astro images. Members of the news, Rob Dick was recognized for his long service and his contributions, particularly in light pollution abatement, as he's now recognized as a fellow of the Royal Astronomical Society of Canada. Rob, are you here? I didn't see you. Rob, congratulations. Well done. All right, next slide. So something else here. Bob Hiller here, our fellow manning our PowerPoint presentation tonight. You remember a couple of months ago, Bob gave he shared with us the TELUS video that was created on the construction of his observatory, the remote observatory. It's about 100 kilometers from here. Well, remember how charming that video was? Well, it was shared at the Cannes festival, and in fact, he won a silver. The video won a silver for corporate media and TV awards just in December here. So congratulations, Bob. It's nice to see. Next, please. Okay. Actually, there is one other slide, one other announcement about. Okay. So there is one other thing that was brought to our attention by Brian McCullough. We have there was 4 Ottawa Centre members who recently contributed some astro images to the Canada Theatre's production of Night Sky. This is I think Brian is the stage manager for that. But during the show, there's actually an astronomy presentation delivered by I guess a fictional professor, and in the background, what you see are images were contributed from Rick Wagner, Mike Wirfs, Paul Clevenger, and Wolf Meyer. So that's kind of neat. And there's also recognition right at the end for the Ottawa Centre for doing that. So nicely done, and thanks, Brian, for bringing that to our attention. Okay, we talked about the Fred Losking Observatory and our plans for the future. Gordon's going to give an update. Gordon, over to you.
Thanks, Mike. Well, good evening. F.L.O. Well, for our tour, so far, as Mike mentioned, stealing my thunder, we have 37 people signed up. There are about 6 people who haven't responded yet. So if you're here and haven't responded, please do. We've got 2 dates that we're proposing. The first one is February 21st rather, the Saturday. Excuse me. What we're hoping to do is have an open house during the afternoon and then a star party when it starts to get dark. Our cloud date will be the 20th, the Friday, which would mean we wouldn't have the open house. But everything, the observatory will be open, the scope will be running, so you can play with the 16 if you want. Our cloud date, if that whole weekend gets shot or is far too cold, we'll figure something in March, probably somewhere around the 13th, 14th. And then the second date is in April, and I believe it's the 10th, 11th.
Okay.
10th?
Yes.
Yep, good. And they're both very close to new moon, so it should be good. And again, we'll do the same thing in April with the open house and the star party afterwards. So if you didn't sign up for the tour and want to come out for the star party, you're more than welcome. If you want to give me a heads up that you're coming, just so we can control numbers, that would be good. The other thing is, as was mentioned a little while ago, we've been given a telescope, an 18-inch Dob, and we have a 14-inch Schmidt Cassegrain that we're trying to integrate into the F.L.O. And it's going to mean reorganizing everything. We're going to need a couple of extra buildings, or we're going to need to redo the existing building. We're going to have to make some decisions about the 16-inch, what we're doing with that. And Ron St. Martin has agreed to oversee the project, but if any of you think you have the skills to help and the interest to help, he'd be more than happy to talk to you. So either get in touch with him directly or with me. And he's going to try and come up with a plan to implement these things, and so we can actually start building, I hope, sometime this summer and be functional before the end of the year. So anybody who has skills or interest, please come forward. And that's about all I have for you right now. So, thanks.
Any questions for Gordon?
What type of skills are you looking for?
Well, that's a good question. Basic engineering skills would be good. We need to develop a site plan. Okay, some of the ideas that have been put forth are to tear everything down, build a whole new building, much larger, with 4 separate observing areas within the one building. And other suggestions have been a group of smaller buildings. Apparently we do have I think it's a 10-foot dome already. We have that, so we need the foundation for it. So just to help work through the logistics of what do we have, what works best, what can we do for cheap that's still good and functional. Anyone else?
Something that keep in people's minds is whatever is done will probably require maybe some contacts and some trades and companies that would like to donate in kind their gravel, usage, machinery, their business skills, something like that, so that people that don't know what they're doing don't have to do the work.
Exactly, yeah. Yeah, I know Ron is making a few inquiries with some contractors that he knows that might be interested in working on it. So, anyone else? Nope. Okay, thanks very much.
Thank you, Gordon. Sounds like a good opportunity for somebody who would like to do a little bit of project management. Okay, next up is Carmen Finstad. Karen is our new AstroNotes editor, and as I mentioned, I think I mentioned earlier, she's also, no I didn't, she's also the national secretary, and I've asked her to say a few things about, we're fortunate to have her in the Ottawa Centre, is also the national secretary, so I've asked her to say a few things about the role of the national secretary as well. Karen.
Thanks, Mike. Did you put up my first slide? Yeah. Thanks. I hope that's legible. I thought you'd be interested to see the collection of names of newsletters from across Canada. I think this is only 24 of the 28 centres. Some of the smaller centres have abandoned their newsletters in favor of a website only. But it's an interesting collection of names, and there's remarkably little duplication with one exception. And I don't know about you, but looking at this list makes me think of the old Canadian Football League and the Rough Riders of fond memory. I don't know, maybe it's an Ottawa thing. Next slide, please. But AstroNotes is our newsletter, and the focus is on our. It's about us. It's about our members, what we get up to as a group and individually, our accomplishments, our activities, our plans, and for members and by members is the operative thought here. I have no intention of writing every issue from top to bottom. I need contributions from as many of you as are here. And it's not fair to expect the Centre Council to write all the articles or contribute all the items. Your announcements, your thoughts, what you've been up to, accomplishments, cartoons, and questions. I have this clever content generating scheme to have everyone send in their questions. I'm calling it NASQ, which stands for Not a Stupid Question. And this could be anything. Maybe you're sitting there wondering what is being spoken of that everyone seems to understand, but you don't have a clue what's going on. What the heck is a smart scope? Who was Helen Sawyer Hogg? And is it true, Karen, that you once had tea with her? Why, yes, it is. Or what happens at the General Assembly? Things about our centre, things about the RASC in general. Basic astronomy questions, up to a point we can find a link or a resource for you. It's not my intention to cover things in the newsletter that you can get elsewhere. You can go to magazines and books and the website to find the web in general to find out about basic astronomy or cutting edge research or the latest equipment. The newsletter is about us and what we're doing. So I want you to all keep in mind what can be in the newsletter, what specific skills are needed, and what is the progress being made on the observatory project, anything like that. So that's about all I have to say about the newsletter. Mike did ask me to say something about my role as the National Secretary. The RASC, as you know, is a nonprofit corporation run by, it has a volunteer board of 9 members of the society that are elected and 1 non-elected member of the board, which is the executive director, who is a full-time employee of the RASC. It's the board's job to oversee the staff at the national office, to set policies and determine budgets, to manage the publications of the society, its investments, its charitable publication activities, and to communicate with the members through the National Advisory Council, the permanent committees, and of course the Centre Councils. As secretary, my duties include writing agendas and taking minutes for all the meetings of the board and of the National Advisory Council. This comes to something like 15 meetings a year. And so far, not a single one has been less than 3 hours long. I have to maintain the official bylaw and policy manual documents that are online, administer the dozen or so national email lists, and don't get me started on that one. I manage the public speaker program, and I write a column for the journal. And that's kind of the tip of the iceberg. I'm 7 months into a 3-year term and still finding my way. And of course, I participate in all the meetings of the board and the discussions, many of which go on via email between meetings, so it's kind of a constant thing. And I have to speak up whenever I feel that the other directors are veering from the path of righteousness, or perhaps just the path of common sense, which happens more often than you might think. There's a lot more to say about the structure of the society in general, and how the board works and what it does with your fees, and how the National Council works. And if there's interest in that, I could come back sometime and give you a longer presentation about the board, but that's all I was planning to say today. Are there any questions?
Karen,
Yes.
will AstroNotes continue to be electronic, or is there any indication of going back to a hard printed copy?
No, I think we're going to move forward rather than backward. The general consensus is that the time, effort, and expense is not worth it. I think that was the consensus of the council, but it's not my intention to do that. However, if you send in questions and say, why are we not doing a paper version, then we can come up with a firmer answer, and if a lot of people want a paper version, that can be discussed.
Karen, I think during the council meeting, I volunteered to reformat it so you can print it out like the old days, but it won't be distributed by paper. And I don't know if it will be posted on the internet, on the website as the PDF booklet, but if it is, then it'll be accessible there. Otherwise, people can find out who's saying this out here in the darkness.
Yeah.
I'll send it to you.
The current version that's posted on the website, and which you receive announcements via email every time it's posted, is formatted in Word, and it's produced as a PDF. And the beauty of doing it that way is that you don't have to worry about layout. Robert, if you want to take that and reformat it and let people know it's available, I think that's fine. I'm going to stick with the beauty of no layout task.
I think I did it the last time, and it was a 5-minute job, and just upload it to you or someone.
Okay, well.
But it's something that I certainly would not reformat. It's just a matter of changing the printing look of it.
Well, I think if you want to do that and make it available, there's undoubtedly people who would appreciate that very much.
By the way, the journal, in the latest letter to us, are encouraging members to get a hard copy of the journal at an extra cost, which I prefer myself. And I would be willing to pay extra for a hard copy of the AstroNotes.
Okay, well, that's something for the council to take into consideration then. Yeah. I believe this month everybody is receiving, or maybe it's next issue. Is it this time? Yes, everyone in the society across Canada received a hard copy journal, and it's got my column on the back page. Okay, thank you.
Here's an idea for maybe an AstroNotes contribution. I know that many of you, when you go on vacation, you sort of seek out the the astronomy sites. You know, if there's a planetarium or something of interest. And usually, if I'm not twisting your arm to share it at one of these meetings here, it's a good idea would be actually just to write a little article on it. Maybe include some photos as well, and we can have it in the AstroNotes as well. Another thing too that some people like to do is, obviously we're limited in time, we can't go on and on with presentations, so maybe you want to expand on your presentation, and one great way to do that is by writing an AstroNotes article, so some things to do. One thing I forgot to do before we go on, I always like to do this, is are there any people here that are here for the first time tonight? Sort of maybe raise your hand. Okay, I see a couple at the back. Well, oh my goodness, quite a few for February. So welcome. We're going to be talking about what our group has to offer a little bit later on. But hope you'll enjoy it, and say hi. I'd certainly like to talk. But welcome for sure. Okay, next up is should be Al Scott. So Al Scott with his 10-minute astronomy news segment.
All right, good evening, everybody. So, straight into the news. You have control? Okay, let's go for the first one. So, the first item I want to discuss is Curiosity's science investigations in Mars. Curiosity, of course, is NASA's Mars rover that's on the surface of Mars, and it's made some interesting discoveries. The rover itself is made to investigate the environment, look for areas of Mars that may have at one time been conducive to life, look for traces of water and organic materials. And so this particular news item is discussing a recent measurement by Curiosity. There's been a lot of speculation about the presence of methane in the Mars atmosphere over the years. There have been some orbiting spectrometers that have thought they detected traces of methane in the atmosphere, and this is an odd discovery because methane is not stable in the Martian environment. Methane breaks down and oxidizes relatively quickly from the solar ultraviolet radiation and turns into carbon dioxide. So methane has a very short half-life. So if methane is present in the Mars atmosphere, it needs to have a source. And one of the potential sources of methane is microbial life. So scientists are very excited about the finding of methane, and traces of methane indicate that there is an active source of this methane. This picture here, the big picture here, shows some of the potential sources and sinks of methane in Mars. Not all of them are life, of course. Only one. That's only one potential. There are other sources of organics which can lead to the discovery of methane, and I'll get into that in a second. The discovery is shown in the bottom left, and this is methane abundance measurements that were made over a couple of years, 20 months actually, and during 2 of those months, in late 2013 and early 2014, 4 measurements actually averaged 7 parts per billion of methane in the atmosphere. And that's not a lot, 7 parts per billion. That's the graph on the left down here. But you can see the baseline is about 0.7 parts per billion. So the actual, looks like the equilibrium concentration is rather low, but there seems to be spurts of methane coming up in the vicinity of the Mars rover. Now this is a very interesting discovery, because what it means is that there must be some sort of local source, and a relatively small source probably, to be able to bump the local concentration up by a factor of 10, and then have it come back down. The rover also detected traces of organics in the soil. It drilled into a rock and measured in an oven organic material coming off of this rock. And this is rock that has been supposedly newly exposed on a rock face over millions of years, newly exposed, quote unquote. It hasn't been exposed to the radiation of space for quite as long as the rest of the surface. And they found organics. So that's really interesting as well. So some of the potential sources and sinks, you can see microbes can create methane through just biological processes, but also the weathering of certain types of rock, olivine and pyroxene, for example, when they interact with water, go through a process called serpentization, and they give off methane in that. And methane can then be trapped in the permafrost if it exists in a clathrate type thing, and it can spurt out if the permafrost melts locally. Also, another source of surface organics or organics in the rock is from cosmic dust, from dust particles. We know there are carbonaceous dust particles with organics on them. These have been detected and measured, and they've fallen to Earth and been measured. So we know these things are falling on the surface of Mars, and by the ultraviolet radiation will then come up into the atmosphere temporarily. This could be the source of the continuous background, but it's probably not the source of short bursts of methane. That's more likely to be either local melting, perhaps, or microbes. So a very interesting discovery. They've also been looking at water. The place where the Curiosity rover is called Gale Crater, and it looks like there's an ancient lake bed there. There actually is clay on the ground that they have taken into their oven and heated up and measured water coming off of this clay. And they can measure the isotope abundance of this water. They can measure the hydrogen to heavy hydrogen or deuterium ratio in this water. And this tells them a little bit about how old the water is. Now, they've dated the rocks that they've measured to about 3 or 4 billion years old. And it's very uncertain, but it's very old. And they've measured the isotope ratio of the water in this rock, and it's roughly half of the current isotope ratio in the Mars atmosphere, and water that's in the Mars atmosphere. And what this means, over time, the water that's in the Mars atmosphere is escaping to space. The ultraviolet radiation breaks it into hydroxyl, OH, and a hydrogen ion. And the hydrogen ions will escape into space. And because heavy hydrogen is heavier than light hydrogen, it preferentially stays on the planet, and the lighter hydrogen escapes quicker. So over time, the ratio of heavy hydrogen to light hydrogen in Mars's water changes and becomes heavier. And what they found is that the water in this rock that they measured is half as much heavy hydrogen as in the current atmosphere. So that means there's been significant escape of water from Mars into space over this 4 billion year period. But the interesting thing is that the heavy hydrogen to light hydrogen ratio in this rock is still a factor of 3 different from what the Earth's is. And we don't think the Earth's water has escaped very much because we have protection with our magnetic field from the solar radiation. So our water isn't escaping to space like Mars's has. So what this means is that a lot of the water had already escaped into space when this water became entrapped in the rock. So probably 3 times as much escaped into space in the time up to this rock forming, and then another half has escaped since then. So very interesting discoveries, real scientific sleuth discoveries from the Curiosity rover. So move on to the next one. This one caught my eye. It's a very interesting system. This is an image of not an image, but an artist impression of the star system J1407, a young K-type star, about 90% of the mass of the Sun, and only about 16 million years old, so young by solar standards. This system is located in the constellation Centaurus, and it's about 420 light years away from Earth. The star there shines with an apparent magnitude of 12.3, so you could see it with a backyard telescope. Astronomers have discovered a planetary ring system that they saw eclipse this young sun-like star in the year 2007. The system, consisting of over 30 rings, each of them tens of millions of kilometers in diameter, is much larger and heavier than the ring system of Saturn. The rings encircle a substellar object, either a giant planet or brown dwarf. If we could replace Saturn's rings with the rings that have been seen around this object, they would easily be visible at night and be many times larger than the full moon in our sky at the distance of Saturn. And you can see the inset here shows a picture of the orbit of this planet and its ring system to scale. So you can see that the rings are a significant fraction of the orbit. Furthermore, they found gaps in the rings which would indicate that satellites or exomoons are forming around this young planet. The details that were seen in the light curve are incredible. The eclipse lasted for several weeks, but there are rapid changes on the timescale of 10 minutes as a result of fine structure in the rings. At times, the rings block 95% of the star's light, of the parent star. The total diameter of the ring system is nearly 120 million kilometers, more than 200 times as large as the rings of Saturn. The ring system likely contains roughly an Earth's worth of mass in light-obscuring dust particles. The actual angular size of the ring system, if you could image it, it's only about 3 milliarc seconds on the sky, so you wouldn't be able to see the rings or image them directly. But because this thing passes between the star and us, we can see it as it obscures the light from the star.
Al, are the proportions correct here? Like the size of the center object with the rings, are all the proportions correct?
We don't really know what the size of the center object is, but the rings are shown in proportion in the upper picture. They're not actually certain how massive the center object is, and that's something they want to find out, whether it's a brown dwarf. They believe it's probably 10 to 40 times the mass of Jupiter. Difficult to constrain from the data that they have of that one observation 7 or 8 years ago. The planetary science community has theorized for decades that planets like Jupiter and Saturn at an early stage would have had very large disks like this around them that then led to the formation of all of their satellites. The Galilean moons, for example, over millions of years. This is the first time that such a process has been caught in the act. The researchers are encouraging amateur astronomers to help monitor J1407, which would help detect the next eclipse of the rings, which are expected probably around 2017, give or take a year or so. Observations of J1407 can be reported to the American Association of Variable Star Observers. This is a very interesting type of serendipitous observation that astronomers can do on many young stars if you could find them. And add to our scientific knowledge, because if these things are common, it's something that's easily detectable from an amateur setup. So, very interesting discovery. Thank you.
So yeah, I think you can see as well that the projector is working a little bit better tonight. I know Tony, you're probably thinking about it, and Eric, you are as well as you're get ready to show your images. So keep your fingers crossed, and I think we're going to see some outstanding images, including some beautiful images of Comet Lovejoy. So next up is Carmen Nelson on my one of my favorite segments of this program, and that is she has a series on historical figures in astronomy. These are people who have helped advance astronomy. I think you'll find her presentation very similar to one we heard. What was it, back in September? I think September or October, where she sort of kept us riveted to our seat. Carmen, come on up.
Hello again, everybody. Glad to be back to give you some more of a history lesson, I guess. So the gentleman I'm going to talk about tonight is Johannes Hevelius. He was a Polish astronomer of the 17th century that actually probably few of us know anything about, especially on this side of the world. And it's very much undeserved because he made many important contributions to the study of astronomy. Next slide. Perhaps you may have heard of him, but maybe not by the Latinized version of his name, which is Johannes Hevelius. If you were German, he would be called Johann Hewel or Johann Hewelke. And in Polish, he's known as Jan Hevelius. And Hevelius himself signed his name as Johannes Hevelius when he was 20 and Hans Hewelke when he was 28. But we all know him now today in his Latinized version, Johannes Hevelius. He was born in Danzig, and that's now modern-day Gdansk in Poland, on January 28, 1611, to parents of German and Czech nationalities. His parents were very wealthy. They owned a very prosperous brewery that brewed the then famous Joppen beer. Next slide. And that beer you can still buy today if you go to Poland. Of course, now they have renamed it Hevelius, of course, trying to capitalize on the name, but you can still drink it. Johannes was the only surviving son of the family. 3 others died very young, and he had 6 sisters. So there was certainly considerable pressure on him to take over the family business. But at age 16, he fell in love with mathematics and astronomy. This due mainly to the inspiring lessons given by his math teacher, Peter Kruger. Next slide. So passionate was Hevelius about astronomy in particular that he convinced his parents to pay his teacher to give him extra private lessons in astronomy. From Kruger, he learned not only the required physics, but also how to build astronomical instruments from wood and metal. At age 19, Hevelius left for the Netherlands to study law at the University of Leiden, but his heart was not in it, especially after he witnessed an eclipse of the sun and saw Saturn veil the moon in a lunar eclipse. And while at university, he also took courses then in math and mechanics and optics, and after 1 year abandoned his law degree and went off to travel. He spent a year in London and then went on to France, where he met with some very famous astronomers like Pierre Gassendi, next slide, and Ismail Bouliot, next slide, in Paris. And he was ready to set off for Italy and meet none other than Galileo. But by then, his parents had had enough of him and ordered him home and told him that he had to take over the family brewery. By now, it was 1634, and Hevelius was 25 years old. Next slide. The dutiful son returned. He got married and studied the art of making beer and was admitted to the Brewers Guild in 1634. But astronomy beckoned again. In 1639, Kruger, his former math teacher, was dying, and Hevelius went to see him one last time. And on his deathbed, Kruger encouraged him to return to astronomy. And so moved was Hevelius by this that he returned home and immediately passed the running of the brewery on to his wife, who, by the way, did a very excellent job. And he began to get busy to build a private observatory on the roofs of 3 adjoining row houses that he owned. Next slide. And that's a picture of, you can see the very large telescope at the top there. Those row houses he owned himself. So he ground the lenses for his telescopes and built mounts for the state-of-the-art quadrants and sextants, and built a very large tubeless refracting telescope with a focal length of 150 feet, which you see in that picture there. Next slide. Here's a close-up of, you can get the perspective of the people standing on the roof there and how large that thing was. Like Tycho Brahe, he built very large measuring instruments and was able with them to greatly improve naked eye measurements of star positions. And he didn't use telescopic sights on his equipment, yet he was able to measure star positions very accurate to the nearest 1 minute of an arc, outdoing Tycho Brahe himself. And over the next 16 years, he had the best observatory in Europe at the time, and he called it Sternberg, that means star castle. Hevelius somehow found the time also in 1641, while all this was going on, to become an alderman of Danzig and then a magistrate. The city of Danzig fully supported all of his astronomical interests, and in 1647, the city gave him a 6-foot azimuthal quadrant. Next slide. That had been lying unused in the Danzig armory, and Hevelius mounted it on his observing tower and used it to measure angles between neighboring stars. These measurements were collated later in a star catalog that I'll talk about in a few moments. But before I go on to the list of his very great contributions in astronomy, I'm just going to tell you a little bit more about his personal life. In 1649, his father died, and in 1662, his wife died, and there were no children from this marriage. And then in 1663, Hevelius married the 16-year-old daughter of a rich merchant. Her name was Katharina Elisabetha Koopman. Next slide. There are the two of them observing together. So he married basically a 16-year-old woman and young girl, and he himself at the time was 52. But the age difference, surprisingly, was no issue for them. Katharina had a very keen interest in astronomy, very unlike his former wife, and observed with him very enthusiastically. And the family grew and they raised 3 daughters. Hevelius and his observatory were famous all through Europe. King Louis XIV of France, next slide. So there's King Louis, visited him and gave him a yearly grant for his work. And the Royal Society of London admitted him as a member in 1664, and Hevelius corresponded often over the next 14 years with his secretary, its secretary Oldenburg, as well as with Wallace Flamsteed and Edmund Halley. And I showed you pictures earlier of Gassendi and Beaulieu in France. In 1660, King John II and Queen Maria of Poland even visited him and gave him their patronage. In fact, 4 consecutive Polish kings supported him financially. King Jan Kamiers visited him in 1659 and raised the family to nobility in 1660. And King John III Sobieski, his biggest patron, next slide, regularly visited him and gave him a very generous visit at the observatory from 1677 to 1683, and in the end paid Hevelius a very generous pension of 1,000 gulden annually and freed him from paying taxes. From 1642 to 1645, Hevelius studied sunspots on the sun. Next slide. It was a very important time to do so because the time period spanned the first part of a period of minimum of solar activity. And he was the first one to call the bright markings close to sunspots faculae. It's a term that we still use today. He was then also able to determine the solar rotation period with great accuracy for the time and much more accurately than his predecessors. Next slide. In November 1644, he observed that Mercury goes through phases. That had been predicted earlier by Copernicus, and he just verified that was true. And for the next 10 years, he began to study the moon. In fact, to this day, he is called the founder of lunar topography. He charted the lunar surface, next slide, that's one of his drawings, and determined that the very large uniform gray regions were low plains and the bright contrasting regions were mountains. He discovered the moon's libration and longitude, and his diagrams of the lunar phases and estimates of mountain heights produced the best maps for at least a century after that. And all of this he published in a work he called Selenographia in 1647. Yet in spite of all this great science, believe it or not, and being the scientist that he was, he actually believed that the moon was inhabited by beings he called the Selenites. The Selenites. That piqued my curiosity. So I did some research on the Selenites. And did you know that they have monthly meetings just like we do? And in fact, I have a photograph of what a typical gathering of them would look like. Next slide. What's that?
Do they webcast them too?
I don't know. We'll have to ask them. Next slide. There they are. Believe it or not, when I was putting this talk together, I went on Google Images, and just for a lark, Googled Selenites. And you would not believe the number of pictures that popped up there. From all these different kinds of scientific, or rather sci-fi websites, you know, modern day, contemporary sci-fi websites. And the thing that I had to really laugh about the most was, here in our 21st century, everybody's still obsessed with Selenites, and that term was coined by Hevelius in the 1600s. Yet the same term is still used, so I thought it was pretty amazing. Next slide. On, Hevelius went to study the comets. So he observed comets of 1647, 1652, 1661, and actually that comet was probably Ikea-Zhang, and 1672, 1677, 1682, and this one was probably Comet Halley. He believed that the comet orbits were parabolic, which actually is sometimes true. It's not always the case. And all of this he published in a work he called Prodomus Cometicus in 1665, and later in 1668 he wrote another book, he called it Cometographa. In 1662 he published a book about the study of the periodic variable star in the constellation Cetus the Whale. Just gotta have a bit of drink here, it's pretty dry up here. Next slide. So he called this star Mira, which is actually the name we still use, and it means the wonderful. And today this star is also known as Omicron Ceti. In 1666, Hevelius was offered the directorship of a new observatory in Paris. He declined it actually, and it was given to Cassini instead. Next slide. Why he did this is clear when you hear what he wrote about himself much later in 1681. This is a quote. He wrote, "I'm a citizen of the Polish world who, for the glory of his country and the good of science, worked so much, and while not boasting much, executed his work with the most effort according to his abilities. In 1670, Hevelius made an independent discovery of Nova 1670 Cygni and was the first to publish a work about it, although it had been observed independently by a Carthusian monk in Dijon, France, 1 month earlier, but it was not published. Because Hevelius had such detailed records of that part of the sky over several years, he was able to write with certainty that the nova was new. It declined in brightness over the coming months, but in 1671, it became even more brilliant than at first. And he studied extensively, not only that, but also Cassini at the Paris Observatory. And then it faded again and was last seen by astronomers of the day in 1672. Actually, it's still a nova in our time. It's called CK Vulpeculae, and a very detailed article appeared in the Astrophysical Journal as recently as 1985. In 1673, Hevelius published Machina Caelestis, a series of... Gotta have a drink again. It's terrible up here. I've lost my teaching voice. In 1673, Hevelius published Machina Caelestis, a series of star maps based on measurements he made of star positions. And it was then that the Royal Society of London began to question the accuracy of his measurements. This was thanks to a dispute he had with Robert Hooke over the use of telescopic sights on observing equipment. Well, Hevelius didn't use them, and Hooke argued that there was no way that he could do proper scientific work without them. So persuasive and forceful was Hooke that the Society on May 26, 1679, next slide, dispatched a very young Edmund Halley, then just 23 years old, to Poland, armed with a 2-foot quadrant with a telescopic sight. So his job was to measure the same star positions that Hevelius did, and they were going to compare their observations, Hevelius with his open sight quadrants, and Halley with his telescopic sights, and they would see who got more accurate results. Well, Halley was not successful. He underestimated the state-of-the-art equipment that Hevelius had owned, and the fact also that Hevelius had very keen eyesight. He could see stars of 7th magnitude, and also what a skilled observer he was. So Halley returned to London, and the dispute was over. Hevelius's reputation was intact. Next slide. Unfortunately, this was not the end of the troubles facing Hevelius. On September 26, 1679, when he was 68 years old and away from home, a coachman left a burning candle in the stable and a fire broke out. It quickly spread to the wooden platform where Hevelius had all his equipment, and in no time at all 3 houses were on fire. Many townspeople came to help carry out the equipment and the documents, and some to steal them also. But unfortunately, all of his instruments, his optical workshop, his printing workshop, everything was completely destroyed. And thanks to the quick thinking of his 13-year-old daughter, Katerina, at least his star catalog and some other books were salvaged. Well, Hevelius was devastated and his health deteriorated. He wrote to the King of France to ask for extra funds and was given them. And this was also matched by the King of Poland, and Hevelius set to work to rebuild his observatory. Next slide. And thankfully it was ready in time for him to observe the great comet of December 1680. Then he moved on to his greatest work, a star catalog of 1,564 stars, whose positions he had carefully measured and recorded since 1657. He charted 16 nebulous stars, although only the 2 that we now know of as M31. Next slide. Next slide. Oh. I think I may have forgotten to tell you this. Go to the next slide. Okay, that's M31. That's the Andromeda. Okay. So only the 2 that we know as M31, that's the Andromeda Galaxy. And the next slide, M44, this Beehive cluster, were actually deep sky objects. And in spite of this, Messier himself actually spent many hours looking for the other ones because he thought that Hevelius was such a great observer that he's got to have, he had to be right about the others when he actually wasn't. Next slide. Unfortunately, this great work was never published in his lifetime because suddenly in November 1686, Hevelius fell ill and died on January 28, 1687. Thankfully, Hevelius's wife, Katerina Elizabetha, completed the book and included 600 more stars that she and Johann had observed together, and it was published in 1690. This is the cover of that book. And after her death in 1693 at age 46, her daughters inherited a complete set of Hevelius's published works, and the eldest, Katerina, inherited the most beautiful of the star catalogs. Just take a look here for a second. I think I'm missing a page. No, okay, I'll go on. Yes, she inherited the most beautiful book of them all. And unfortunately, Katerina had married a very greedy husband, and he sold most of the books to a museum in Russia, but he didn't include the star catalog manuscript. In 1734, during the Russian siege of Danzig, a bomb fell directly on the room where Hevelius's manuscripts and instruments were being held by the son-in-law. But the star catalog miraculously was not damaged, and eventually it was given to the Danzig Institute of Technology many years later. Then at the beginning of the Second World War, the Germans moved it to a nearby village. And when that village was heavily bombed, the star catalog once again miraculously survived. And it's now kept at the Utah Brigham Young University, and it's been there since 1971. It's as if he were in space looking down to Earth. Strange that he would do that, because who in that day could go out into space, but... Anything else? Okay, thank you.
Thank you. I can't imagine just how much research Carmen did. You know, a real true labor of love. I imagine it must have been months and months of research and just to prepare this presentation tonight. So thank you again, Carmen. Well done. I thoroughly enjoy it. Okay. Before we go to break, I wanted to say a couple of things about membership benefits, particularly for those of you who are new tonight. A couple of things that we have here. We have a telescope loan library. It's very similar to a book library. You can except you sign out telescopes. Al Scott, who's the librarian, he's here tonight. If he's the fellow who spoke about the 10-minute astronomy news segment. He can, if you have any questions, he can talk about that. Actually, if you want, you can also Google the Ted Bean Loan Library, and you'll see pictures of the telescopes. At least some. We even have even more than what's shown on the internet there. Next slide, please. Some of the other benefits with your membership, you get a yearly subscription to Sky News Magazine. You get the electronic version of the RASC Journal. Of course, this month, as Karen mentioned earlier, every member is getting a printed edition. You also get the Observer's Handbook, which is available now in electronic version. I mentioned that. I believe it's now at $10 more if you wish to have that handy. Well worth it as well. And then I know that AstroNotes, Karen will do certainly a fine job. Next slide. So if you're interested in membership, it's a yearly fee of $72. Of course, if for family members, if you want to have a family membership, it's $67 base cost plus $10 for each additional $10 for an adult. So and then $5 for youth. And there's a youth membership. There's a standalone youth membership as well. Next slide. And next slide. Triangulum minus, the small triangle. So, as I said, I'll just go back to what I was talking about earlier. Unfortunately, this great work was never published because then Hevelius fell ill and passed away. Next slide. So, after his death, then this star catalog miraculously just survived. It had gone through many different hands. It ended up almost being bombed and so on, and now it's now kept at Utah's Brigham Young University. It's been there since 1971. It's still there. Next slide. That's the first page of it. Next slide. So the name Hevelius, thankfully, still lives on in the sky. In 1931, a main belt asteroid called 5703 was named Hevelius by K. Reinmuth of Heidelberg.
And in 1935, this crater on the moon that you see, the large one in the center, was named after him. It's 118 kilometers in diameter on the western border of the Ocean of Storms. Next slide. And there was a stamp issued in honor of the 400th anniversary of his birthday in 2011. And next slide. And there is a statue of him in Gdansk. Any questions?
Question?
He named the fly Musca, M-U-S-C-A. He named that because it was shown in the northern hemisphere. It is present. There is a constellation in the southern hemisphere with the same name.
Oh, really? Oh, I don't know.
It's not like on one of the maps.
It was on the map? Do you want to go back?
Yeah, go back about 3 or 4. Right there. That one, right in the middle. Right.
Oh, Musca there.
Yeah, that's actually a constellation. Did he name that?
That I don't know.
Because it does exist in the southern hemisphere. It's not the same.
I don't think he did name it.
Okay.
I don't think he did. But could always Google it, but I don't think he did. I don't recognize that name because I went through most of the plates.
Any other questions?
I forget the name of the beings he thought lived on the moon.
Selenites.
He was a great observer. Did anything mention that what he observed that led him to that conclusion? Did he see something that he interpreted as cows? Or
It didn't pop up in what I had read. I think it was just, he just was a dreamer maybe.
Beer.
Yeah, maybe. Yeah, too much beer. Too much of his family beer.
Carmen, how did you find him? How did you find out about this film?
I have a book on just general names in astronomy. I think it's by somebody north. And I was just reading a chapter, and he was talking about constellations, and then he said, oh, and something about, yes, and Hevelius was one of the ones who did something, and he never mentioned him again. I thought, Hevelius? I've never heard of Hevelius before. So I looked at another book of mine, and there was a little bit more on it, and then I just started Googling, and I was shocked, actually, at how prolific he was. And yet, I don't think has anyone here ever heard of him?
Jim?
One. So it was a big shock to me, but especially since he had done so much work on, the topography of the moon and everything else that we just sort of take for granted now. And the constellations. Mm-hmm.
Those star charts mirror images as if they're looking from the other side?
Yes, I forgot to mention that. Right.
There's some image was backwards.
Yes, right. It's as if you were in space looking down to Earth. Strange that he would do that, because who in that day could go out into space, but. Anything else? Okay, thank you.
Thank you. I can't imagine just how much research Carmen did. A real true labor of love. I imagine it must have been months and months of research and just to prepare this presentation tonight. So thank you again, Carmen. Well done. I thoroughly enjoy it. Okay. Before we go to break, I wanted to say a couple of things about membership benefits, particularly for those of you who are new tonight. A couple of things that we have here. We have a telescope loan library. It's very similar to a book library, except you sign out telescopes. Al Scott, who's the librarian, he's here tonight. If he's the fellow who spoke about the 10-minute astronomy news segment. He can, if you have any questions, he can talk about that. Actually, if you want, you can also Google the Ted Bean Loan Library, and you'll see pictures of the telescopes. At least some. We even have even more than what's shown on the internet there. Next slide, please. Some of the other benefits with your membership, you get a yearly subscription to Sky News Magazine. You get the electronic version of the RASC Journal. And of course, this month, as Karen mentioned earlier, every member is getting a printed edition. You also get the Observer's Handbook, which is available now in electronic version. I mentioned that. I believe it's now at $10 more if you wish to have that handy. Well worth it as well. And then I know that AstroNotes, Karen will do certainly a fine job. Next slide. So if you're interested in membership, it's a yearly fee of $72. Of course, if our family members, if you want to have a family membership, it's $67 base cost plus $10 for each additional $10 for an adult. So and then $5 for youth. And there's a youth membership. There's a standalone youth membership as well. Next slide. That came out from the basically as a high resolution Hubble images of the Andromeda Galaxy. So let's see if that works. That's mainly I put out a call for door prizes, and wow, we got quite a few that came in. So that's always nice. All right, the next segment is the observer reports. Now this is where I'm really hoping that our resolution is improved quite a bit, so I'm excited about that. So let's use this, because we have a little bit more time in this meeting, let's use this to have a lot more sort of interaction with our observers, and feel free to ask them lots of questions on how they prepare their images and so forth. So first up, we actually have a number of oh yes, I forgot, of presenters. The first one is something that I'm sure many of you have seen from that came out from the basically as a high resolution Hubble images of the Andromeda Galaxy. So let's see if that works. pretty impressive. Okay, yeah, for sure. Okay, next up are our observer reports. First, you're up, Jim.
Sorry, take your time. Talk slowly, we have lots of time. Okay. So this image was meant to be presented actually several months ago, but because of the Christmas break and such, I didn't get a chance to. It was taken on the 20th of December with my 10-inch RC scope, and it's of an area on the west side of the moon called the Marius Hills. It shows up better here. Is there a laser pointer here?
Yep.
The green dot?
Yep.
These little pimples up here, each one of those is a volcanic dome, roughly 1 kilometer to 2 kilometers in diameter and 200 to 500 meters tall. And there are several hundred of them in this area. And it's been an area that I've tried hard to get a good image of. Because it's so far onto the western limb, you have to get the terminator just right to get the nice long shadows cast off of each of the bumps. And if you do a little online research of this area, there's also a pit that's famously known as the Marius Pit, I think, that's been recorded by the Lunar Reconnaissance Orbiter. And it's just an area where the surface has caved in, and it's like a cave, basically. It's visible from orbit. So that's a neat shot that I was happy to get. Next, please. So another shot of the moon. This one was taken a little bit more recently. It was on the 14th of January, on one of the rare clear days that we've had this winter, and exceptionally cold. I believe it was around minus 25 when I took this, and it was around 6 in the morning, this being one of the later phases just past last quarter. Again, it was with a 10-inch reflector, 2 times Barlow. I especially liked the fact that sun was setting on the crater of Copernicus, so just the last little lip is illuminated. And I don't know if you can see down on the bottom, these little goosebumps down here casting quite long shadows. I thought that was pretty neat. Like, these features are probably only maybe 500 meters to 1 kilometer high, but they're casting shadows that are on the order of 30 kilometers long, which is kind of neat. Another couple clusters of volcanic domes. There's 5 of them there. You can actually see the little crater at the top, the caldera, and then there's a big one over here. So more evidence of volcanic activity on the moon. Next one. This was a shot, again, another rare clear day in December, taken with a 4-inch refractor and a Bader safety wedge. I used 2 different filters. The top one, calcium K, and the bottom one, solar continuum, which is a narrow band in the green spectrum. But then I just captured the image in grayscale. But when people talk about the effect of the atmosphere on your seeing, you can see the difference in the clarity of the 2 images. The top one is down in the UV band, so down deep in the blue and purple, where the atmosphere affects that color range more so than more towards the red. So that's why one of the reasons why the solar continuum is so much clearer. It's just a effect of the atmosphere. Anything else to note on that? The one thing that I was impressed by, I wasn't expecting to get such a nice shot. This is sunspot group 2241 and 2242, by the way, if you want to look them up later. There's a lot of solar flare activity from this group at the time. But this was very low in the sky. It was like the day before the winter solstice, so it was about as low in the sky as it could be. It was about 20 degrees above the horizon for me, just clearing my neighbor's house. So with it being that low, I wasn't expecting to get any kind of decent seeing, but I ended up being pretty lucky. Next one. So this is a more recent shot. This is from the 31st, using the new solar scope that I got. It's actually a H-alpha filter that I can put on to any scope that I want. In this case, it was a 2.5-inch refractor that I put it on. And this is actually a composite of several images taken at different exposure times. So short exposure to get the features on the face, and then a longer exposure to get the prominences.
I have a question. Is the projector distorting the shape?
Yes, it is. You can see it by the round.
Why does it look not round? Because the sun is not round. It is slightly oblate.
But that's exaggerated there. The projector is creating a problem here.
Probably tonight.
It's possible, yes.
Okay.
But it is slightly oblate. It's even more so on the screen here. It's about 2 to 1 on this screen. At the time that I captured the image, I caught a bit of a minor flare happening. I don't know what sunspot group number that is, but I caught a bit of a solar flare there. And what I was really impressed by was the size of this prominence up in the northwest. Since I've been observing H-alpha, I hadn't seen a prominence that large before. And it was quite fascinating to watch. If we go to the next one, please. This is with 4 times Barlow added. The detail in this prominence, it can just make out the little wispy details here. It's better on this screen here, the gamma is higher. But even within the course of about a half an hour, this wall of prominence would break up into multiple loops that would then recombine. It was fascinating to watch. If it wasn't so bloody cold outside, I would have stayed out all day. So that's, I think all I had, that was it, wasn't it?
So Jim, you were saying this is a new, what was it again that you purchased for your scope? Why did you do this?
Yeah, it's, you can get these from several different makers, but it's a combination of an etalon, which is a special interference coating that you can tune to be exactly on the frequency for hydrogen alpha emission in the sun, 656.3 nanometers. And that's combined with a blocking filter, which goes down by the eyepiece to further narrow it down and cut out all of the infrared and UV for eye safe. And you can buy these to use with your own refractor. It has to be a refractor. Reflectors, it won't work because it's too much energy. But yeah, the one that I got's made in the UK. It's called Solar Scope. It's fairly expensive. I got it used. I wouldn't have bought it otherwise. But Lunt also makes a similar type device. Or you can buy a dedicated solar scope, which is the same thing, but they just throw in the scope with it. But it's the same kind of idea. A tunable filter on the end and this blocking filter. It's like a system that works together.
These are outstanding.
Okay.
Thank you. Next up is John Thompson.
Over the last couple of weeks, I've been following Comet Lovejoy and was able to get several images of it. This first one was taken on January 20th, and it was minus 20 degrees that night, and I do have an Ioptron star tracker, but it was too cold to try and get it set up in a line, so I tried something I hadn't tried before, at least not for comets. I have a fairly fast telephoto lens, a 135 millimeter f2.5, so I set an intervalometer like an external one, to take 3-second, actually this was 5-second exposures. So this was a stack of 24 5-second exposures, which gives the effect of 2 minutes. And then I used Deep Sky Stacker to stack them all. So this was taken from my back deck, and it was just a fixed camera on a fixed tripod, no tracking at all, and Deep Sky Stacker rotated and translated the images to give the effect of tracking. So you can see a bit of a tail there. That was January 20th, I believe. Is there more?
Yep.
Okay, now that's the same image that I processed through a program that I discovered a few months ago. It's called astrometry.net, which is the front end, the guts of it that actually allow you to do plate solving. And image identification is called nova.astrometry.net. You can upload images, and in most cases, about between 10 and 20 seconds later, it comes back with a complete solution showing any deep sky objects in it. It shows it'll give you the RA and dec of the center of the image, the pixel scale, the dimensions in degrees, and it'll also show you the orientation with respect to north on a sort of a global star map. So this one, there was a couple of deep sky objects there. I went and looked them up to see what they were. The NGC 1156 is a very faint galaxy. And NGC 1170, it turns out, is a non-existent, one of the ones called non-existent, not by the RNGC, but it was reported by 2 astronomers in the 1800s who had been observing a comet, and then just a degree or two away from the comet, they discovered this little patch of what they thought was nebulosity, but it's never been seen ever since. So the thought is it might have been a knot in the tail of that comet. So anyways, there was 2 people were on record in the original NGC as seeing it, but it's never been seen since.
Excellent.
This one was taken on the 26th of January. And this was 3-second exposures. That's the equivalent of almost like 4.5 minutes. It was, I believe, it was about 70 3-second exposures. I found by trial and error that what I can do sort of conservatively is 400 divided by the focal length of the lens gives more or less the maximum I can take without excessive trailing. In this case, I did blow it up a bit so that that was cropped and blown up by a factor of 2 or 3, so you can see the trailing there, but in the original image, there's very little trailing. I mean, again, you see a bit of a tail coming out there. And
that's it?
Okay, there was one more I took last night. I wasn't sure if you...
We didn't get it.
Yeah.
Sorry.
Okay. So anyways, that shows what you can do without a tracking setup, that you can actually take, if you have a fast lens, you can take numerous, 3 to 5 second images and just stack them, and it gives the equivalent of a tracking system. I've got my camera here that if anybody wants to talk about it, I can show you.
All right, thank you, John.
Okay. Thanks, Mike. Okay, so this is an image of Comet Lovejoy that I took back on January 20th from Teeples Hill, which I like to go to lately because it's really dark. The comet was about 45 degrees above the horizon when I started imaging it, and so it differed from a lot of other comets I've attempted in the past in that typically you have a comet that's close to the horizon and you've got maybe 30 minutes to image it. So that presents a problem in terms of the exposure time that you want to, that you can get, and so typically you just use a one-shot color camera. In my case, because I had enough time, because it's so high, what I decided to do is use my SBIG STF 8300 monochrome camera, and I used my LRGB filters to capture it. So what I did though is I took 3-minute luminance images, followed by 1 minute each of red, green, and blue. And typically when I'm taking pictures of deep space objects, I'll take all the red images together, all the blue together, all the green together, all the luminance together, and so on. And that just allows me to not have to change the filter often and have to refocus. But for this comet, I decided that I was going to risk not focusing in between each image, but because I'd go a luminance red, green, blue, and then luminance red, green, blue again, over and over and over, what that would do is allow me to have separation in the stars when I went to go back and process it. And so what I captured 2 hours of exposure on this, processed it in PixIm site, and I figured that I would process 2 images and put them together afterwards. So what I did is I aligned on just the comet and then just on the stars, and that gave me 2 images that I could then combine later. For the comet, there's a function in PixIm site called comet alignment, and that allows you to specify on the first image where the center of the comet is, and then on the last image, and then it computes based on the time in between for every image when it goes to align it, how much the comet has tracked, and then stacks it together, aligns it together so that the comet is sharp. And when you go to integrate it afterwards, what you do is you, in my case, I use a Windsorized Sigma clip algorithm to integrate it, and I set the Sigma high value very low. And what that does is that because say when you go to stack, say, the luminance image, each successive luminance image is separated in time enough that the stars then are far enough apart that statistically they get rejected. So if I could, well, here, I'll show you in a second here. I've got a second image with just the comet without the stars. But first of all, though, what I did is I took the other images I stacked the images together a second time, and I aligned them using the star alignment tool to get the stars round. Otherwise, if you were to just stack on the comet, if you were to stack on the comet with it moving like that, you would get stars that would blur, right? So I needed the second picture where the stars were then sharp and the comet was blurred, and I used a tool called Star Mask then to be able to extract all the stars from that image and subtract the comet that was effectively blurred by doing it that way. I then took a tool called Pixel Math and used the maximum function to combine the 2 of them to get this image here. So I'll just show you the image I took without the stars. Is this one right here. And what impressed me most about this one is that when you go back and forth between the one that has stars, it's funny how the stars kind of distract a little bit from it. I've had a lot of people tell me that they like the one with the stars better, yet when you go and look at the one without the stars, you can see more of the detail in the tail itself. So anyways, I was just reading before coming up here tonight, the guy that discovered this, Terry Lovejoy, he discovered this thing with an 8-inch telescope, which to me is pretty impressive, because with an 8-inch telescope, you're not really pulling in all that much light. So anyways, thanks.
Go back for 1 second here. Eric, I want you to take a look at your one back, I guess. I can do it. Eric, this is pretty impressive. You need to look at this. I'm sure you've looked at it a lot, but this is, I think it looks nice here in the auditorium there. This is outstanding work. And do other people agree with me that this should be submitted to Sky News and this is outstanding. Astronomy Mag, this is APOC quality, I think. You know?
If you put this on next year's calendar, dude.
Yeah.
Actually, Eric, that's an excellent idea.
Well, thank you.
I'll make a note of that, because I think that's a really, really good point.
I haven't seen a better photograph of Lovejoy than that. Has anyone else seen a better photograph?
I haven't.
Wow.
And this is really something to have from a member of our group. Eric, this is outstanding.
Thanks.
It really is. Okay, next up is Tony. Tony Peterson.
I just want to amplify those comments. I was texting back and forth with Eric that night. I was worried about him. It was very cold. He had off-roaded through the snow to get to one of the highest points that you could in the Madawaska Highlands on a night when the forecast low in Ottawa was minus 25 and it was windy. So he was enduring less than minus 30 out there. His equipment was barely working. He had to connect to his mount with his Ethernet cable. Is that correct? That was the only way he could get it going? Okay. And so I congratulate him just for getting home alive, let alone getting out. I really think this is fantastic stuff. Okay, have I got control?
You have control.
It's this one? It's this one. It's this one. That's backwards.
Next one? No, that's
Oh.
right.
No,
Right
there we
one?
go. Right one.
One more?
Okay. So first I wanted to come clean about something that I missed in my presentation last week. Particularly my image, my mosaic of the Cygnus region. A couple days after that on APOD, this image popped up. The Soap Bubble Nebula, which was discovered in 2008, so it's not on any of my charts at home, my computer programs. And I looked at this and said, hey, this should be actually in my H-alpha mosaic. And so I went looking for it. And indeed, in the top right-hand corner, oh yeah, just pause here for a moment. This is the image I showed last week. This is a 3x3 mosaic with an 85mm refractor and hydrogen alpha from my backyard. And so just coming in there from the top right, and oh, I had to blow that up a bit. Yep, okay, right there. So it is 4 arc minutes across and a bit, about 5 light years across. It was discovered in hydrogen alpha, but it's a much stronger emitter in O3, so it's not a very impressive image. But I just wanted to say I got it. Okay, so I'm going to do a little experiment because when I print my photos, I realize that I have to tweak the brightness, the dynamic range, and so on to get the same result in a photograph that I think I see on my computer screen. And I would be surprised if this projector is not the same. So I'd like to know what one needs to do to an image to make it look its best here in the auditorium. So I'm going to show 4 images, 3 galaxies at a globular cluster. And the first one is going to be the original. And then I've changed the brightness in 2 different ways. And so I'm just going to take a poll. Please tell me what you think looks best. This is the original of NGC 891. And so that's with the bottom end brightened a bit. And that's with the mid-range. Should I go them again?
Yes.
1, okay, 2, 3. And I can obviously increase the effect. There's nobody, I'm resounding, the crickets are chirping. Back to 1. You like the high contrast? Okay, let's try another one. This has actually a little too high contrast. The Dierlich group and Stephan's quintet. I think that one's got to be a little better. And number 1 again. Really?
The background's too light.
Okay, well I did this is with the dark end boosted only. This is with the mid-range boosted. Okay? Still 1. Wow, okay, and then 31. Okay, this is an old image. This is hydrogen alpha boosted. Boosted. Okay, this is a separate H alpha image, a very deep one, 43 times 1,000 seconds. I subtracted the red continuum and then threw it back into the image so to bring out the H alpha emitting clouds. So there's no. Okay, what about that one? Oh, that's overblown. Okay, it might be different for a globular cluster. So here's M13.
That's
Okay, so this is a bit different than a galaxy. Yeah.
There's more stars.
More stars, and don't forget there's this little tiny galaxy over here. You want to be able to see that? 3 for this. Okay, so take it easy on galaxies, but pump up the stars. Okay, that's all I wanted to show.
Tony, are you happy with this? What are your thoughts?
Oh, well, obviously it's a huge improvement. I mean, what's important is that the dynamic range is much better in these images here. I mean...
Which of those would you use to print?
Sorry, what?
You said you
Yeah, I forget the name of the company. It's a printing shop on near the corner of Somerset and Bank.
Right, but would you send them 1, 2, or 3? They would come to a better.
Oh, I would do something very similar to 2. What I discovered when I printed them is they say they've got an 8-bit printer, right? And they accept 8-bit images. I printed 256 grayscales from pure black to white, and I looked at what you could see there, and I decided that really they're printing at about 7.6-bit. You need to compress both ends in order to get something that's got the full range from white to black. So I didn't do exactly that for any of these, but this is similar. I pumped up the dark end.
What camera are you using?
For this one, it was a Parsec 8300M Orion, yeah, which is now hors de combat.
All right.
Okay. That's
We got a fine selection of images tonight. Holy smokes! All right, let's go on here now to the finish up the meeting. I guess I can do it. Okay, so if you'd like to know more about the meeting and the various various members responsible for the meeting here, I talked, for example, earlier about I always talk about you, Al, the lone librarian, the telescope lone librarian, and that is, I hope I'm doing the right button here. That's, of course, Al. And as a member, you obviously get, you do get discounts on Sky and Tel and Astronomy magazine as well, Stephen McIntyre. If you want to get all their email addresses, it's go to this URL here, and it'll get you that information. We do have a normal library, as I mentioned in previous months. That library is still at the Science and Technology Museum, but I understand it's not far from being, it's not long before it's going to come over to here, so the members can continue to benefit from that. Okay, after the meeting, we have a social event which is open to all members and non-members alike. It's at Perkins Restaurant, which is at Saint Laurent and Ogilvy. Everyone is welcome. And for those of you who aren't aware, we also, you can see all the cameras here. We record this meeting, and it's also being live streamed as well on the internet. We post the videos on YouTube and on that, and shortly after the meeting on that Ustream location. So thanks. We said how many tonight here, Bob? About 90. About 90 people, which is pretty good for a February. I mean, it's usually one of our worst months in terms of attendance, but I think we did very well. Thank you very much for all the speakers, and thank you especially for the group that helped out prepare this auditorium. We had a few surprises with the auditorium, but that's another story. But we got through it. The next meeting is on Friday, March the 6th, and I'm same time, same location. I'm excited about this meeting for a couple of reasons. One of them is Tim Cole is back. Remember, he gave the very best, the 2014 presentation. The best presentation was awarded to Tim for his presentation on the astrolabes. He's back with another presentation on celestial navigation. Okay, and someone I'm working on and I'm looking forward to is Dr. Haley Sapers. And she's an astrobiologist, and we're bringing her to the center for next month, and I think you're going to find her talk on the origins of life by looking at the early rock record that on Earth and on Mars. And she's going to be exploring the conceptual meaning of life, and some touching on some of the philosophical definitions of what is life really when you're an astrobiologist. And I'm really excited about her presentation. She's a very impressive person, as you'll see, and looking forward to that. I hope you can join us. So at this point, we will close the meeting, and I'm going to do the prize for the. We're going to draw the prizes for the draw for the door prizes, and we're going to officially close the meeting. Thanks very much. And by the way, we also have a photon pump as part of the door prizes, so whatever that is. So on the internet, thanks for joining us, folks, and that's it. So let me. Bye.